Okay, so we thought we'd have this conversation sort of following a certain direction. We'd ask you about your personal trajectory, but only as relates to science, what brought you to science, etc. And then about your professional trajectory. And then advice to students and thoughts about the future of science and the field. So maybe you can ask your questions also in that order.
Yeah, maybe the student better ask this kind.
So, but I'll ask the first question maybe, and then to get it started. So when and how did you decide to become a scientist?
So at high school, I was kind of a mediocre student, except for mathematics. That I went to a humanistic high school, where I studied for 7 years Latin and for 5 years ancient Greek. So the mathematics was very elementary, so I didn't need to study it, and then I was still the best in the class. So it was a natural vocation to become a scientist. At the beginning, I was uncertain whether I wanted to be an engineer or a physicist. And the deciding factor was that to be an engineer, you have to be, in those days, you needed to be able to draw, and I was totally disastrous at that, and so decided to become a physicist, and very deep reason. No, there were other reasons. I'm just telling the story in a joking way, and I never regretted. I never regretted. Has been the best choice of my life, scientific. I mean, that was a job for me.
But there was no family pressure. They let you choose whatever you wanted.
No, my parents were very liberal in this respect. So no, there was no pressure whatsoever. I was free. I know my father was a doctor. In his heart of hearts, he would have liked me to follow, but he didn't put any pressure. It's only.
Do you want to ask anything in this about this area of his life?
Yeah.
Yes.
Okay.
Were you ever confused going to this line? Meaning, was there any plan B? Well, if this did not work out, what will you do?
No, there was no plan B. I just went. In a sense, there was a plan B. Okay. So what I did, I started studying in Messina, which is my hometown, and then I was a good student, contrary to high school, and so my father decided to make the sacrifice to let me work in another city. So to make study in another city, I went to Bologna, and there I studied. I mean, there was no, in those days there was not so much condensed matter, almost nothing. So the scene in physics was dominated by high energy particles. So I did the title that was given there, the doctorate title was given there in Italy, la laurea. I did my laurea in relativistic field theory. So, but then happened something which, there are many instances in my life where something bad happens that turns to be positive. That was one of the first circumstances, because my supervisor that said, okay, so now you did a good thesis, you can come to me. I spent a couple of months in Geneva, because elementary is the capital, and then I'll call you to join. So I'm still waiting, being called, because he got sick. It's some depression, something, maybe because he had me as a student, I don't know. But and so I had to find another job. And a job with one of the few condensed matter people, Tosi, and he was coming back from the States, and so I changed field. And this was my second, my second lucky circumstances. Without that, no, probably I would do some stupid string theory or something useless. You know, I had a lot of fun.
Any other question from a student?
It?
Yeah.
So are you apprehensive about changing fields after your PhD? Because you have been trying to do high energy physics and later you shifted to...
But it was not so deep. I mean, you had to learn a lot of things, but there is a basic unit in science. And so many of the things that I learned, that's field theory, Lagrange, and they tend to be useful. And in fact, they were actually immediately useful, because first thing I did was some forgotten things about electron gas, which is many-body process. I did many-body theories where the formalism that I had learned for studying elemental particles turned out to be useful. And also the thing which is relevant is that this study, they gave me frame of mind, and also a lot of courage, because having been had a door slammed in your face and being able to survive and not thrive, that makes you stronger.
Was there anybody in particular who inspired you early on, who you thought, I want to be like that person?
Not really. Later in my life, I had a lot of great people. I had the luck, and I can't get tired of repeating it. I wish I could be like Anis Rahman. And that's close to impossible, because he was a unique human being.
Can you say
Yeah,
a little?
there is some question.
Yeah.
So you said that you were kind of working in the many-body electron part,
Yeah,
right?
yeah.
And during that time, there was CJEC, and many great people who were working on that field. What made you change from that? Because it was kind of a more developing field that back then.
Yeah, because that was the interest of the professor I was working for at the time.
Okay.
Then I started doing other things more related to statistical physics, liquid state theory, and this and that. But that was accidental.
Oh, okay.
Was the circumstances of life led me to this.
Yeah, because
to this thing,
yeah.
and I found so. One plus of this non-linear path was that I thought, if you wish, I was born a scientist interdisciplinary.
Yeah.
So I didn't get any fear of changing or mixing one field with another field, things of this nature.
Were you fascinated by computers or not at all?
Not really, not really. I was not very good. I mean, I did very little, because, but stupid things, plotting a function. Now you do by use the computer, plot the function. But no, I was for the first part of my life, scientific life, I was a pen and pencil person. The change came when I visited Anis. That was just my Damascus. And also that was very accidental. I had a big problem with one professor in Trieste, whom I will not mention, and I decided to change air, to get away for a while. And there was this possibility of spending time with Anis in Chicago for 3 months. Okay.
But why him?
What?
Why him?
Because of him, because I knew Priya Vashista. I was friendly, because Priya also did electron gas, so he knew me through this earlier activity. And he asked me whether I would be interested, and the project was to work on super-ionic conductors. I don't know whether it's what's used in your batteries. So they're compounds which are partly solid and partly highly mobile. Huh? So compounds, the lithium battery, a solid state, are super-ionic. So the lithium can move, diffuse, and conduct electricity, but there is a scaffold there which remains more or less fixed. And we had to do silver sulfide. That was the job. Finding a potential for silver sulfide. And you know, constructing a potential silver sulfide is not exactly immediate. So we discussed maybe we can do a simulation and so on and see the phase transformation and use this, use the energy of the ground state to fit the potential and so on. And immediately Anis told me that, look, if you try to do that, there is a problem because the ground state of silver sulfide is monoclinic, if I don't recall. Okay? The high temperature is some form of cubic, symmetric. So we have to impose periodic boundary conditions, so you cannot fit both things. Otherwise, you create a lot of defects and so on. And so that I had just read the paper, I think very famous, important paper by Hans Andersen, on constant pressure simulations. So we had the idea of extending and so on, and that's how the Parrinello-Raman came about. And originally I was supposed to stay, as I said, 3 months. I stayed 2 years. And then I went back to my job in Trieste. And then after a few years, Roberto Carr came to Trieste. And we worked together. And that's Carl Parrinello. And now you can see all my past and the Lagrange and this and that. So although I did many things in life, in science, not so much in life, but there is such coherence.
Another question? Saurabh?
So I want to ask you one thing. So is there anything else except science you are interested in? Even you want to become like a footballer or a songwriter, musician, anything except scientist?
Okay, when I was a boy, I would have loved to be good at sport and be able to play music. I was terrible at either, so I was a goalkeeper. But then I had to wear glasses, so it was the end of my goalkeeping career.
What do you do now when you're not doing science?
Okay, as you know, science is such a science, it has two facets. There's the real work that you do, and there is a very strong human component, which fills you also the non-work part of life, because, you see, I stay here with you guys, I work surrounded young people. It's such a fantastic privilege that you have no idea as you grow old. So they're kind of my, I wouldn't say family to specialized words, but kind of that. It's a part of the warm and strong community, which, okay, so that's what I want to say. But then otherwise, I like going to concerts, most classical. I like also opera. We are lucky where I live, we are not too far from La Scala in Milan. I can go and listen to that. We hike, we visit friends, it's a normal life. The scientific part is not, I don't think it's normal, but
Meher.
it's very likely.
How often do you mention science at home? When you get a result, when you publish a paper, when you get an award, what are the occasions on which you broach the subject of science at home? Or is it forbidden?
No, we don't. We don't.
Forbidden.
No, my wife has given up, but occasionally my relatives, like, like my brother and so on, they try to say, "What are you doing? Can you explain it to me?" And that's often a difficult question to answer, especially when they say, in generically term, I think they have an idea. What are you doing these days? Metadynamics.
But you mentioned that your daughter has gone into science, so was she influenced by you, do you think?
I think she's, I mean, she's great in my eyes, maybe greater than she actually is, but no, I think it's a realistic assumption. She's very gifted, and she wanted to do science, but then she decided to do biology, and her main motivation was there was a field as in science, but as distant as possible from what I was doing. Yes, so you didn't do mathematics.
So whenever I ask anyone that how to give time for the extra activities, I always get an answer that prioritize. And whenever I prioritize, work comes first. So did you have...
I didn't get the question, okay?
Yeah, question, I'll ask the question now.
Yeah.
Did you ever have to prioritize your work on top of your extracurricular activities? That's like you wanted to do this, but you couldn't because you have to work.
If I have a regret in my life, is that because of the intensity of the work, I didn't spend with my daughter as much time as I should have. That's a honest thing. All the other things, if I cannot go to count. Well, if I cannot meet a friend, that's hard.
My question is, what did a typical day of your PhD life look like? Were you the typical extremely disciplined student who would be there at 8 or 9 and work till 5, or would you go off to the library to read a certain book to understand a certain thing?
I'm the most unstructured person. No, there was no structure in my
In
case.
that context, what characteristic about the way you did things helped you the most, you think, in where you've reached today?
I think what helped me were the years, something which is, you young people will have difficult, I mean, you probably will not be allowed to, but when I was in Italy, I got very early a permanent job. In those days there were openings, amazing. And so the job security was not was there, and I had a lot of freedom, and I could study and look at that, a lot of curiosity. And also the other thing which I found it very helpful, and now it's impossible because of the literature has become so mongoose that you cannot follow what happens, even in your own little field. Okay. But in those days, I remember there were very few, much fewer journals, and they would come through the post, you know. There was something you open and read it, go to the library. And I spent many hours. So when there was the new batch of journals that would arrive to the library, I was there reading also, I don't know, nuclear physics, astrophysics, I mean, all sorts of things. And I think this has been the ground on which what came later has been this. I don't think time. I try, that's something that I miss. I think nobody. So if you look at the ratio of publication to the time that you have, there was a young, who was it?
Basically, I wanted to ask about how you approach a certain problem. Say you want to study a certain feature about the system, say, okay, let's say the transport phenomena of a certain kind of ion, say in a certain kind of framework. How do you approach it? Do you first look at the physical aspect of it, then the mathematical aspect, then go into coding it, or how do you go about it?
Typically, I don't look at things, methods in an abstract way. So I told you how the Parrinello-Rama came. I'm known for many methods, but I started from a physical question and then developed the method. So the Parrinello-Raman thing was quite a clear situation. But in general, that's because you want to do certain things and you don't have the means, so I try to see whether there are tricks that can be done to help. But I also like the physics, and so whether they like it or not, I'm very close to what the guys in the group might remember that going, sitting on shoulder and say, what has happened tonight, and so on. So, and then also I like the understanding of what goes on. So not only doing it, but also understanding, if possible, and having an idea of the physics.
So there are people who have spent their whole careers doing Parrinello molecular dynamics, for example.
I pity them.
Yeah, but you keep moving on to new things.
Yeah.
So is it because there are questions that are bugging you, or is it because you get bored, or what is it?
I mean, I have to be honest. It's a combination. I mean, ab initio is very powerful. I like very much, and you can do many wonderful things. But there is this problem of time scale, and so that's why I engage myself with the issue, with what became metadynamics and all the other things.
Okay, right at the back.
I would need some water.
Okay, maybe since the mic is here. Sorry, you have the mic. You can ask. Yeah.
So, what drives you? The curiosity you have, or the challenge you like to take up challenges?
It's a good. I don't. That's not the way I work. I mean, I function. I'm a curious person. I want to be able. I like to compute things, and so if there is a good problem that I want to, I would like to be able to sort it out. That's how it works. It's more problem driven than.
Okay, at the back there.
Yeah. So if I may say, I mean, when I was a young man, even after the degree and being young professor, I thought I was nobody, very mediocre. Not mediocre, no, but one like very mediocre. And I never thought I would have made such a career. And so you don't know what's inside you, okay?
Yeah. So I find some papers unnecessarily of first getting all the main points through complexity of language. What views do you have on them? Why is it not directly specified? Or like recently I find some papers which write in a very difficult way to get through the lines.
There are two issues there. People is in a hurry, and they don't spend the time that is necessary to write a paper. Again, turn your head to may have, and he will tell you how long does it take to write the paper with me, even after the calculation are done, because you want to make it understandable. There is another issue, because now there are many disciplines coming together, statistics, machine learning, statistical mechanics, and so on. If you look at this literature and you see the languages that they use different terms for the very same concept that is used in physics. So there should be a way of unifying this thing. On the other hand, the science is science. So the way you call things has to be precisely defined, as it is in chemistry. So if you give it a name and so on, you know exactly what you're talking about. So it's not a place for ambiguity.
This is at a slightly higher level. So when a new PhD student joins you, so how do you handle the PhD student? How do you train that person? I mean, do you just...
So he's a professor, not a student.
No, what happens, I mean, in the last decade, I had the luck of having great people and also large groups. And I always strive of making my group be like a community. Because in other culture, like in the United States, every little thesis is whole desk, and then because is afraid of what the next neighbor will do. And so most of the time we have a community where everybody helps everybody else, and the older people help the younger, and sometimes the younger are smarter than the older, and it goes the other way around.
Yeah. So this is in continuation to what Nimish was asking. So you were saying that you love to do computation and you enjoy doing it. So do you think, like many people say that when someone is doing science, they say that they would like to be, like whatever you do should be solving some problem that will be benefiting the society or something. So do you consider that aspect of science for an inspiration for doing this, or like that it should be helpful for the society, whatever we do?
I think what we do, if it's correct, well done and meaningful, it's of help to the society. Full stop. Full stop. Given the same two problems that look similar, if one has a greater impact, then of course you should, potential impact, you should look for that. But it should be I can allow myself to do that at this stage in my career, but I mean, it should be the scientific relevance of the problem to guide you. Because then in the end, maybe not next year, then in 5 years' time, in 10 years' time, you will see. So when I started doing Michele Parrinello, I never thought it would be of any use. I just wanted to do that. There was the melting of silicon to look at, and so on. And then it came a tool which is used not only in academia, but also in industry. It's used everywhere for solving practical problems.
So, just sort of the same question, slightly generalized. If you're a student and you're thinking of starting an independent career, how should you pick the problems you work on?
Oh boy, something that you're passionate about. Without passion, it's not. I don't think the utilitaristic thing works in science. It's something that you like doing and like solving.
But don't you think nowadays to get your science funded, you have to pretend at least that it is useful?
There used to be like this also in my days. But in my days, it was enough that you say the sentence. Now you have to be more elaborate. So, what can I say? Maybe, I think we should balance the two things, because there are two extremes. One, people that do irrelevant things, okay? So that's not the way to do it. They do because they like it, they like the mathematics, whatever, but that's not relevant. And the other mentality is to be driven by application on a very short time scale. They're both nefarious.
And should you work on a fashionable topic or something no one else is doing?
That's a good question. I try to avoid working on fashionable things, because
but you create the fashion.
Well, why? Because it's like when you mine, you have a mine. If everybody goes there, find the nuggets, it's extremely difficult. So if you go in another area, and then there are lots of low-hanging fruit that they can pick before the other. And you don't need to be super accurate, super this, because you found that, you discover America. You don't need to draw the coastline, the moon. So it's better not to go to super fashionable things. Also, people become nasty and fashionable.
Mm-hmm.
They shout at one another.
Do you think science is becoming nastier?
No. The nature of the nastiness has changed a bit. Was more personal. So I remember, that doesn't happen any longer, ATS meetings, and where people shouting something. J.C. Phillips was one such person. He would stand up and even so this happens to a much lesser extent these days. But human nature is what it is. Also, the try to be nice to you, or downplay what you did, the non-court, this. So it's a human endeavor. It's one of the most noble human endeavors, but it's run by people. Huh?
Okay, question? Madhulika? Oh, sorry, Pavan, you have the mic, okay.
Somebody is working on a problem, and that problem is taking unnecessarily long time.
What do you mean by unnecessarily?
So, but the guy has a feeling that he can solve the problem. But how can he just hold the nerve?
Well, that's the responsibility.
So you mean when do you give up, or do you pursue it, or do you give up? Yeah.
I mean, if you are a student, that's a responsibility of the supervisor. Try to understand why you're stuck, if there are serious reasons for being stuck, or if there are chances that you can overcome the hurdle. Actually, the supervisor should be careful in giving the problem so that no such things appear, at least for the initial part, because if you get immediately an obstacle, then you're discouraged, and that's the end of it. Then, if you are on your own, it's your own decision. It's a cost-benefit. Sometimes what I do, I stop and then I come back later. That's a good thing. So you do other things, you clean your mind, you look at the problem with different eyes. You can make a step forward.
Okay, next question.
Taking up from Professor Shobhana's comment about science being nasty, getting nastier or not, I just want to speculate on something. Now we are living in an age driven by information mostly. So we are driven by more and more of data and statistics. So as a theorist, do you see a kind of a rising competition in our minds between data and fundamental science? Or is it an amalgamation of both?
No, I don't see that. it's a new tool that we have. There's a lot of, say, it's a fashionable thing, new data, which it doesn't, and don't think that that's the emphasis relative to the result, the ratio, the resources a bit not super exciting, but will be with us forever as one of the tools of science, of modern science, as machine learning. There are tools that will have to learn. They will not solve the problem. Okay, superconductivity, big data would never have been found out.
But do you think machine learning is a sort of different paradigm for doing science that will give us things we can't interpret?
No.
No?
No. No, you have to interpret at the end. I mean, machine learning will do the computation.
Yeah.
Okay. You have to, if anything, to learn how to extract the physical information out of what comes of the machine. But if you look at this neural network as a mathematical tool, they have fantastic properties. They do things which you represent a function of multivariable. So they have many body wave functions that have been written in this way. Also for us, this many potential, or 3, 4 dimensions, how do you have? They have the property that they can represent with accuracy this complex. So then you can solve inverse problem, like doing the inverse of Laplace transform, and things which, so when I look at the literature, oh my God, I said, there were situations in which I wish I had in my hand these tools when I was younger.
Shrikant?
Yeah, I want to ask a slightly different version of this question, which is not about data, but to quote Rutherford, or rather to paraphrase Rutherford, who said, all of science is either physics or stamp collecting. This is what he's supposed to have said.
Physics?
He said chemistry is stamp collecting.
No, but I want to restrict myself to...
I don't understand.
He said, Shrikant said all of science is physics or stamp collecting.
That's what, no, I didn't say that.
No, I don't agree with that. I'm a physicist, but...
No, excuse me. Yeah. Rutherford is supposed to have said it,
yeah.
But I want to paraphrase it. I think just restricting ourselves to physics research that goes on today, we could in principle categorize it into real science or stamp collecting. And so I want your views on how much of each do we seem to be doing if you look over your career from 4 decades ago to now. Is this changing in a healthy way or it's not?
Okay, I don't know how to interpret this story of stamp collecting. I think it was rather for the demand. The object was chemistry.
Yeah.
And this mentality was very pervasive. When I was a student, high energy, even within the high energy people, okay, either you did the most sophisticated abstract, the equivalent of string theory, or you were considered a chemist with this day, so the lowest of the scientific beings. I think this has changed also. This has become less, it's confined, this mentality to a ever more restricted set of people.
But I want to ask you what you think of string theory.
I mean, if I were to be now,
we're amongst friends here.
No, sure. Somebody said, quoting Pauli, not even wrong. It's beautiful mathematics, but unless somebody is smart and finds a way to really
test it experimentally.
Yeah, sure.
Yeah.
That's kind of stamp collecting. very noble. And also the mathematics should not be underestimated. That's important.
Okay, questions?
Yes.
Lots of questions. Okay, you with the mic.
Yeah. So there's a saying that knowledge and science should be free. Then there's also the saying that if you're good at something, don't do it for free. So given all the hard work that goes into writing codes and programs and packages, do you think these should be monetized, or should they stay as open source and accessible to everybody?
Okay, you're talking about the code. It's a complex question. My nature, I prefer, and my codes are free.
Yeah. Okay.
But that comes, and I think since they've been developed with public money, we have a responsibility to give back this thing. On the other hand, we cannot do a professional job. So if you have a package thing, then it's foolproof and so on and so forth. There are many advantages for doing that, but it should be recognized as a contribution of. So I find a bit unsettling that you do something with public money and then you earn money after this work. That I find ethically questionable. So the alternative would be like what we are trying to do with Plumed, that there's a whole community that works around it, or it's been done with the Quantum Espresso, and they keep professional and so on. And that's, but you need a very large number of people for doing that.
Okay, we have to wrap up in 2-3 minutes. So if you've already asked a question, I don't want you to ask again. Somebody who hasn't asked before, like you.
What do you think these new things come from the experiences, or understanding of the subject, or your creativity? So, or it is coupled to all of it?
He's asking if you make a discovery, is it from your creativity or from your past experience?
From my luck.
Okay, I think we pretty much have to wrap up. Meher, you want to say one last thing? In the meantime, while the mic is going, I want many of these people, one thing they're really thinking about, these students, is how do they pick their postdoc position? So do you have any advice for them about that? Should they pick the same area, a new area?
I mean, again, there's not a unique answer, in my opinion. If you don't like the area, get the hell out of there. Okay. You will survive the change. I mean, I'm a witness to that. I don't want to do a boring thing all your life. So that's it. And then the other thing, you will establish a human relation with the guy, and you have to be kind of sure that there is the right chemist. That you, even if it's very good, but it's very nasty, that's not a favorable situation. And especially the ladies are very good at capturing these features.
Sorry.
Getting this feeling.
Yeah.
Getting what the chemistry is.
Okay. Meher?
Is it painful to leave one area and make a transition to another research area like you did multiple times? Because maybe you are more productive in the previous area and you have to suffer quite a bit.
There is another side that she asked me, but I get bored. So,
what about geographical moves? You've also made lots of geographical moves.
Okay, so I was born in Sicily, went to Bologna, back to Sicily for a few years, Trieste, Zurich, Stuttgart,
So you're
Lugano.
saying, so it's quite confined in one part of the world, but you still moved.
But, I mean, that means I've been.
I should explain that.
No, I've been postdoc in Great Britain when I was very young. Also, I spent these 2 years with things, and I spent long times actually.
Because in
the
India,
States.
the usual pattern is you get a job as soon as you can, and then you stay there for the rest of your life till you retire. So,
well, that's not me, but of course, everybody has his own thing. So, when I left Trieste, I left the security of a state job. I went to a company to do research in a company, which is it's better paid, but more precarious.
Yes.
In fact, I left after 5 years.
So, would you advise me that people should take risks, or is it vary from person to person?
It varies from person to person, and even if you take a risk, you shouldn't be foolish.
Okay. Meher, you want to say one last thing? Yeah.
With your permission, I'd like to have a quick rapid fire round of 4 or 5 questions.
Okay, you can ask them.
Okay, thank you. You have to answer very fast. Then if you want, you can explain. You should not think before you answer. Switzerland or Italy?
Switzerland.
Coffee or tea?
Coffee.
Computation or physics?
There's no difference.
No difference. You have to pick.
One
You have to pick.
or the other.
You have to pick.
I have to pick. You mean, what do you mean? Physics without computers or computers without physics?
Okay, you win. You win. Materials or biology?
I'm fascinated by biology, but not too little to be.
Meher or Shobhana?
Oh, voilà! Any moment.
Okay, so we finish, and we thank all of you for coming, and of course we thank Michele Parrinello for being so gracious to spend this time with us.
It's my pleasure.
And thank you, Meher, also for organizing this, and thank you, Dilip, and for spending time with us to help organize all the sound, and we thank the camera people for spending their time with us, and thank you, Nikhil, also for having the original idea. Thank you, everybody.